Hello, welcome to Automat Live Coding. For those who don't know, Automat is a project that we are working here on this stream. It's an environment that can automatically control the desktop by right now clicking mouse buttons and pressing the keyboard buttons. It has some built-in facilities for recording macros, so I can record a quick macro. This is our recording, and now I can play it, and it will press the right keys. I can create loops, so the macro can play in a loop. I can combine it with other macros, because this cable, it's like everything reacts in real time to my actions. So when it's disconnected, it doesn't work. Hook it up to a timer, something like that, for instance. So it started the timer, and in 10 seconds it's going to press the keys. Anyway, so Automat is a macro recording environment, like automation environment. However, we are designing it in such a way so that it can be extended. Like as we add more interesting objects to this environment, it becomes something more general, something that can be used for other stuff, except just playing games. And one thing which we recently started doing was we recently became interested in the problem of control flow. So when execution follows a path, Automat has a very simplistic model right now. Execution always flows through an object to the next object. There's not much kind of variation, except maybe timeline. Timeline can send signals to the objects that it controls. But in general, if you think about this, you could come up with like 10 or like 20 different objects that could help you arrange multiple objects. It becomes a frequent problem. Like in games, when you want to do a macro that will do something repeatedly, you often want to repeat some action, for example, 1,000 times, and then, for example, go back and do something else like once, and then repeat it again 1,000 times. This kind of stuff. It's very exhausting to record this kind of macros. It could be done if you edit the text file directly, the text file with the macro that we recorded. But it's really not the best way to do it. The best way to do it would be to have objects that can do it for you, like an object that can repeat something 1,000 times. And instead of creating 20 different objects in Automat, we have a different idea. We are creating an environment for building those objects within Automat itself. So if you come up with a new type of object that you would like to do something, you will be able to create it from the built-in primitives. And we are doing this with assembly. So we've been working on these assemblies for the past 2 weeks, and so far it's progressing surprisingly well. It's actually going better than I expected. I expected that we would hit a wall after initial prototype, or even during the initial prototype. But yeah, it seems that all of the bets that I thought were risky, they seem to be coming along nicely. So LLVM was a big risk. I was slightly concerned that this is going to be too complex, or it's going to pull some dependencies, cause some issues. It's hard to predict with those kind of large projects. It seems to be working nicely so far. So we managed to implement an object that can represent an instruction. This is the green box here. I can run it, right? That's not an issue. Here, I can run it from a timeline even. So now a timeline runs an assembly instruction every, I don't know, every some seconds. The thing is, this assembly instruction by itself, it doesn't do anything interesting. It's just setting a register value, which is then overridden pretty much immediately by other code. So this is one object. We'll have three of them. The three of them will have to work together to create a working assembly environment. So this is done. The next one was the instruction factory. It's something that we already prototyped during last stream, but we prototyped it only within browser. So this is a piece of JavaScript that it can filter instructions. So I can select all of the instructions that read this register. A register is represented as an icon. For example, all the instructions that read AX. And maybe all of the instructions that are, let's say, 8-bit, only 8-bit instructions. There are not that many of them. There is a list. And we can narrow this down. For example, I want to have a multiplication instruction. And those are the two multiplication instructions that affect 8 bits of array X, which is AL. Sorry, if you don't see. And this fancy page, it's not actually going to look like that within Automat, right? That would be fairly boring, not interesting at all. It has to look cool. So I've been playing yesterday a little bit with the design. I've just started, so we'll probably do more of this design today. And my plan was to symbolize instructions instead of a table, to show them as a deck of cards. And by moving your mouse over the deck of cards, you will be able to rotate it, and different instructions would appear, in front of you. And then you will be able to grab the one that you're interested in. So by default, the deck will be 17,000 instructions. Quite a lot, right? And as you select filters, it will get smaller. The flags below the deck, they will be used to filter by the instruction size. So those will be those flags. And the roses on the branches will represent categories. For example, base or math or logic or system. There are plenty of types of instructions, and they form very unbalanced hierarchy. So my plan is to represent them as a tree, because this is a very natural tree-like structure. In this tree, a flower could represent a type of a category of an instruction. Within a single category, you still have a lot of instructions. If I remove those filters, you can see that we have 2000 add instructions, 2000 subtraction instructions. A lot of instructions. I'm not sure if all of them are subtraction. Maybe they are, who knows. So this is part of the design. There is also register selection with this part of the table, which is going to be probably above the cards. We'll have to symbolize all of those icons here. And clicking each of them would basically, it will enable some kind of filter for the cards in the deck. So this is how instruction selector is going to look like. I will show you more in a minute. The last type of object is the assembler. I've been thinking so much about this. So the problem that we are dealing with in Automat is that we have to model like a part of reality, like a complex problem in a way that's intuitive and convenient to work in. There is this whole branch of computer science called, or maybe not branch, let's just call it like a corner of computer science called object-oriented modeling, where we try to transfer reality into some frames that can be expressed as object-oriented system within computer memory. The problem with instructions is that the instructions that we are dealing with here, I don't want them to be usable just for execution. I would like this object to be something slightly more general, something that actually represents an instruction. And there are a couple places where we would like to use the instructions. First of all, we could try to execute them. This is the situation we are in. But if you look a little bit forward, like what we want to do with Automat, since we want to automate playing games, we will be interested in reading the memory of other games and like hooking it, doing stuff there. So we cannot stop with just execution of instructions. We really need to think about like the big picture. This is something that represents something in the memory of a computer. It can appear in different contexts. Sometimes it appears in our own assembler, where we execute it, and sometimes it will appear in the memory of some foreign process, where we will use this to analyze, for example, or hook it. So this inline execution, this is actually something that we are already doing. We should not, like the plan is to do it in a thread. This is the plan for today, by the way. But then eventually we will also be interested in analyzing other apps. External apps tend to have a lot of code, like multiple megabytes of code. So actually, I think we could even say like 100 million instructions, something like that. Like large projects, like, I don't know, like what? But I guess there are projects like that. Or maybe 10 million. Yeah, probably closer to 10. If you look at like a really complex piece of software, a web browser maybe, it will probably have something around 10 million instructions. We could create this many instructions in memory, and we could like map them directly into the stuff in the other process. But it's super inefficient. This is a common pitfall of object-oriented modeling. It's that it tends to produce overcomplicated and too numerous representation. I mean, just inefficient. Like we could have like 10 million objects in memory, but it will just slow everything down. We don't want to have as many of them. So it makes sense to actually not model the whole memory of another process, but to create those instructions on demand. And those instructions, they will behave differently. The ones that we use to represent our own instructions and the ones that we use to represent the memory of foreign processes. The memory of foreign processes is generally harder to patch because there are some offsets in memory that have to be maintained. Whenever we patch a function, sometimes there is just not enough space to inject new code. So pushing the code, away and patching it to fill all the holes, sometimes it will be just very difficult to do it like that. It doesn't make much sense to run an instruction which is located in another process. In our process, sure, we can run a local instruction because we can sandbox it, we can track the values of registers, we can actually make use of the sandbox instruction. In a foreign process, like some things don't make sense. So it is a big challenge to come up with an instruction object that contains just the necessary part of this concept and that moves all of the irrelevant part elsewhere. Yeah. Okay. Right now, within our instruction, we have two pieces of information. We have the MC_inst object. This is part of LLVM. That represents a machine. Or maybe we could say concrete machine instruction, because there are other pieces in LLVM that can represent generic types of instruction or a class of instruction. MC_inst is very specific. It doesn't have to have all the properties filled, but it can represent an instruction from any kind of target machine. So it can be ARM, x86, WebAssembly. Within our object, we also are storing the address of the instruction, so it knows where it's loaded in memory. This is something that I also think is fairly universal. I think whenever you have an instruction, if it's a freestanding instruction, it can have address of 0, then you know it's like it's not actually present in any memory, it's just an abstract representation of an instruction. But if it has an address, we can know that, hey, it's actually located at this memory, and we can actually attribute this memory to some other process or object. So we can tell whether it's a memory of a foreign process or a local assembler. I'm not sure if we want to put the size of the instruction into the instruction itself. Maybe not. So when we want to execute an instruction, and there are also some issues that we have to fix, because I have this plan so that when you put several instructions in chain, right, when they connect, when they form a basic block, so to say, they should execute consecutively by the CPU. So the CPU shouldn't take any breaks to go back into into Automat code, because we want to have like a zero cost, essentially, assembly execution. To track this execution in the visual environment that is Automat, we have to do some bookkeeping. So first of all, objects that are executing within Automat, they get a flag which is called long running. For example, this timer, when I start it, it becomes long running. When an object is currently running, trying to run this again is generally causing it to cancel its execution. Like, we can tweak this behavior, but generally the idea is that Automat can represent arbitrary processes that are just running for a long time. An instruction is something like that. Instruction can take a long time to execute, for example, a syscall. But when an instruction is running, it's actually not running alone. We also have this extra object that represents a separate thread of execution. And when it's running, that object should also have a flag, meaning that it's busy. This extra object is something that we will be doing today. So this is going to be a separate object that is going to be responsible for executing assembly in a separate thread. This is a rough sketch. It's not how it's going to look like, but generally speaking, this is going to have a hand. Yeah, so here is a hand, beautiful hand. And when it's running, it's going to point at an instruction that it's executing. When it finishes execution, so execution finishes at the last instruction, so to say. Anyway, that last instruction will be able to have a pointer into another object, for example, a timer. So this executor, we need to come up with a name for this thing, and it needs a good representation, really good representation. Maybe eyes, who knows? I think this could be, yeah, I think we'll come up with a nice design, but we will do this later today, maybe in the second part of the stream. Okay, but just to show the complete picture, here we will have like a sequence of instructions. They will look like somewhat like that, and they will all be on a scroll. Yeah, so the executor will jump over this. Okay. Actually, when I think about this, we could use a proper puppet here. I mean, that could really be... I think the visualization will be pretty cool. It has to have a hand, but the hand could be nicely animated. We can use inverse kinematics to draw an elbow. Who knows, who knows. Anyway. I guess this is for the introduction. I can also show you the plan for today. I have this roadmap. First, this is the master project, so I already introduced it. We want to turn the assembler into an object so that it appears on screen, so that when in Automat I type, I execute an instruction, it should automatically create the assembler object for us. And then we will make it run in a separate thread. So, let's get started. Close those things. Okay. Instead of assembler, it's now going to be called library assembler. This is because we use assembler library prefix to indicate that it's an object. It's part of our object library. very weird issues I'm getting. I haven't been seeing those issues before, where I cannot build because of some crash in the Python script. Okay, stuff is working. Now when I run this, I need to do this differently. So this library assembler, actually not going to do it here. So we used to have this global object, which is no longer going to be the case. Okay, now our instruction has an issue because it cannot locate an assembler. There is another object, macro recorder, that we have. We will use. Pick a nice color. Can I do it here? I wish there was a better color picker within this environment. Anyway. Okay, in this function find or create assembler, I think it should always return an assembler, because if or maybe not always, there is a possibility of an issue. Somebody could point to another object. Maybe this assertion shouldn't be here. Anyway. I think we also need a version which doesn't create any assembler. Actually, there is this search radius. Are we setting it to any value? So the thing with assembly instructions is that we don't want them to be explicitly connected to any assembler. Maybe they should be. So this is let's do it like that. Okay, so when we've been doing this setup development, something here, we entered this create, so we created an empty location. Cloned the object. Okay, we call the relocate within the instruction. This is our relocate, line 36. Okay, I think this find or create assembler didn't work. Create from prototype. Yeah, we need to give it a prototype. Okay. And there is a new function that we should override. So construction of the assembler is fairly involved. Anyway. We could disable cloning. Yeah, what to do if construction can fail? Because it can. An instruction that says assembler not found. Yeah, we need to increase the search radius of this instruction. So we are searching explicit connections. Actually, I think it should be explicit, maybe. So I want instruction objects to automatically create an assembler for themselves, and to always use this assembler, like regardless of where they are. I think I will list this instruction then. this argument, I mean. I would visualize this connection differently. We will have plenty of different types of connections. So this is something like yeah. Assembler not found. To move the screen for it to refresh. Okay, it's a detail. So it can find a connection to the assembler, and I guess I can execute it now. Yeah. And now it will crash. Oh, why does it crash? Because when I run it, I'm doing this find or create. I think we can get rid of those blocks here. I wonder whether those functions are getting called.
Wojciech Krawczyk says,
Yo, make PP.
Hey. I wonder why we don't have any text now. Oh yeah, I know. I messed it up because here I disabled the live object code. We have an instruction that says assembler not found, but when we try to execute it, it will create an assembler object, and now when I zoom in, it refreshes texture, it can actually format itself properly. But when I move it away, it doesn't know how to format its own code.
You get this guy by yourself? Or is it any library?
It's a library. It's the same library that Chrome uses to render the user interface. It's this one. There are some guides how to use it. It's usable from Dart. Actually, it has plenty of bindings. Like, this library is available in pretty much every language. So many graphical glitches I would like to fix, but I cannot. They're so distracting. For example, the fact that the connection disconnects from the object when I drag it. It's not a lag issue. We literally have a piece of code that remaps the connection position, and there is like a bug there.
Looks very smooth, I use QT.
Nice. Or the text, the assembler, it jumps. It's not moving smoothly. It should be moving smoothly. It's like slideshow. Anyway, I have to investigate that. Okay, I would like to, when we are too far away, actually not. So first of all, I would like this object to automatically create an assembler to display itself. So here,
Why not QT, by the way? You just more familiar with Skia, or you think it is better for this purpose?
Qt has two issues. First of all, and the big one is that it has some assumptions how the user interface should be constructed. So it really puts you in the frame of hierarchical widgets. I mean, we are using hierarchical widgets, but the widgets that we are using are we are just hooking the rendering process so much, like injecting shaders everywhere, stretching textures. It would still be possible in Qt, but it would be an uphill battle. Then there is the baggage. So Qt comes with a bunch of other Qt-related technologies, like some XML, some mechanisms for like sending signals. We don't need that stuff. Okay, let's try to follow this stuff here. What's happening? I bet it happens because of this, because we are creating an assembler here. It's time to build a debug build. Okay, and now we can try to debug this.
Is your app uses multi-threading?
Yep. Okay, this is a Stack Overflow. We haven't seen those in a while. So we have this. Okay, let's start with the text function. We are trying to find the assembler. Yeah. Nothing surprising. Find object, yep. Oh yeah. So to compute the shape of the object, we need to know how much text it produces. But to know what text representation of the object is, I see. We can prevent recursion with something like that. Okay, if it's multi-threaded, so I can't use that trick. Let's change the fallback widget.
TRI says,
Yo,
Hey, okay, we don't need this debug version. This should still crash. Okay, but now it should work. So by returning like a fixed value, we are preventing the loop on the stack. The instruction is chunky though, so maybe you can make it smaller. 6 centimeters. Yeah. So when I have an instruction and I move it out, it doesn't create an assembler, but when I zoom in, actually this is an interesting crash. Yeah, when an object is disconnected, it can create many assemblers now. Okay, now what I want is, instead of having a radius, a search radius where it connects to different assemblers, which is, by the way, interesting. So it's like a bunch of different executors that can execute code. So there is one here and another here. Each of them will have a separate thread.
Wojciech Krawczyk says,
What pushed you to start Automat project? Do you still do any cheat-related stuff? I did 2 huge bots to games, one in C and one in Python, one internal and one external.
TBI, I guess, like from your previous chats. Yeah, I do this with pretty much every game, and even if the game is... There are like 2 categories of games that I like to automate. There are, let's say, RPGs, like I don't know the good name for this category of games, but there is like a category of games that require you to grind levels. So leveling, gold, random drops. This is whatever game you pick which has those features. Automating this game is like a sport. It's just super fun to do. And then there is the other type of game, which are logical games, where the challenge is to solve the problem kind of on paper. And you don't play this game automatically, you just want to write an automated solution. And there are some games, yeah, usually logic games. So those are the 2 types of games that I like to automate. And whenever I play any of those, I usually do that. Even in Factorio, I used to have like a macros. I used to have some macros that were I used to quickly execute some actions.
It is funny because I did bot to Tibia, but it is based on memory reading stuff.
Yeah. And I actually wonder, because I haven't been using cheat engine myself a lot, I usually do just like reading proc maps. Like I'm using the Linux interface to read memory. How do you usually do this in I guess Windows, and for like Python or C++. Are there some Win32 APIs or some libraries to do this kind of stuff? I wanted to remove this radius. So there are a couple of places where we are using this variable. Here are the important ones. And what I want to do here is I want to say yeah, infinity. I wonder how this will affect the rendering. Lol, stuff just seems to work. I'm not complaining. Can I run it without issues? Yeah, I can.
In Windows, you can read memory, as you said, by CE, and it is the easiest way to find some addresses. But in Program, you can just scan the specific module to find address.
Cool. Thanks. I'm asking because I'm curious about the techniques that are used to do this on other platforms. Okay, I guess we can keep it like that. Okay, I will make a short break here. After break we will do the separate thread change.
Generally, I used Ghidra and sometimes 86 dbg.
All right. This bit is a little strange. It says running machine code at and then crazy high address. So I think our assembler wasn't able to map memory at low address.
This assembly code works similar to code case.
Let's see. So the way it works is that when we create this assembler object, this, I mean it's a block now, but it actually represents a thread. It's not an assembler like an assembler. It's like an object that controls a separate thread and it can pause it, resume it. It maintains the state of registers. It's more like a tiny VM. And those other objects, instructions, they tell the assembler object what instructions do we want to put in memory. So it takes care of filling the memory with those instructions. And when I want to execute one of those, it's actually not executing straight away. Yeah, this is in Automat's module. This is actually the responsibility of this object. If I didn't have this object here, if I replaced it with, if I came up with a different object, so instruction is fairly generic. I wanted to use to just represent a generic instruction, but not but, and it's going to be usable both within Automat and as a way of manipulating external kind of code.
But where those instructions are executed in what memory module?
Yeah, so this object here, the assembler, this, in the constructor, we allocate some memory here. This is just private executable memory. And when we want to update this code, then we mprotect, we emit the assembly, including some prologues and epilogues. We fix addresses of instructions and then we mprotect again. Mprotect again to make it executable. On Windows, this will be done in a slightly different way because, like you say, Windows has modules, so I will look into that. But the general flow is going to be identical. Speaking of, Let's open our prototype, because we are moving into separate thread now, right? So this is a small test case that can actually create a separate thread, which we then trace.
Interesting concept, but I do not get it how assembly code could automate something external. Could you make any real example of how it works?
I had something here. So this is a small example, like minimal test case. The problem, what's the problem? Typically in macro you have a section that you want to repeat many times, and after you repeat it many times you want to progress like to the next phase and do something else. So repeating stuff. So this is the task. So this is how this could be done. We have an instruction that sets the AL register to some value, I don't know, for example 4. Then what we do, we decrement this register, and if it's not 0, we'll have another instruction called JNZ. And whenever we insert an instruction which has a like PCRel offset, PCRel offsets on the x86 are only used for jumps. So we can detect that, and we can set this widget in such a way that the user will be able to pull a connection, and for example pull a connection into external object like a timer. So this way we kind of have an assembly code which counts like from 4 down to like 1, and it invokes the timer this many times, and when it's done it proceeds like to the stuff. So there could be more assembly code below, or it could just end here. So this is a way to connect execution of assembly and execution of other Automat objects. Yeah, we need to implement some more widgets so that it can be seen inside the environment. But we'll be working on the design docs, like the design for the assembly system today. So we have still quite some things ahead of us. Okay, this is boring. Actually, this is probably not the right way to do it. Okay, we're actually not going to use this at all. Okay, this is not a very important piece of the machinery. There are other more interesting ones. Okay, this is very weird.
So you assembly to, for example, store a value of how many times macro should do a task, and after reaching some of condition you will move to the other task.
Yeah, exactly. So it's like using assembly as a scripting language, but we are jumping between like Automat, like the high-level objects, and assembly. We're just closely integrating with assembly. It's like nothing magic about it. It's just a very tight integration.
But is it not too complicated to typical user?
We will see. It could be complicated, but it could be not. There are games where you kind of do something like that. There is Human Resource Machine. If you recognize those pictures, it's pretty much assembly. And here you can draw pictures to indicate what you store in each register. And then create a bunch of, like a sequence of instructions. And this is not exactly how it will look in our case, but we'll do it slightly differently. Actually, sentences are a really nice representation for assembly. Oh, see, jump if 0.
All right, dinner time. See you soon, dude.
Yeah, see you around. Okay, what do we do now? We have signal handler. This is irrelevant. Irrelevant. Actually, prologues and epilogues, maybe they are slightly relevant. think we can use those macros. I know that in LLVM we have register classes, and probably register classes will be more general way to store this. Let's see if we can access this. So we have this register info thingy. Oh wow. This is a generic interface that will work on any architecture. Nice. I think it will be still easier to, instead of having something generic, to just have our macro. Let's do this side by side. Okay, so we are defining a struct that can hold all registers. For now, I will just call it regs. So I cannot hold it here because this object, and there is a bad name, it's more like Let's just call this regs for now. We will rename this. In the constructor, we will initialize regs. So we have this object in memory. Okay, we have this funny structure where the prologue is at the very end. It's fine. So we are saving the initial registers, bx, bp, blah blah blah. So we are filling array X with some value. I mean the address of the place where we keep registers. We will start by saving the RSP. Or actually the base address is stored in array X. Yeah, exactly like that. Looks good. Nice. And this is our jump. Cool. This is not this instruction. This should be move 64 or 64A.
Says, hello Rexel Barbeg. This is a reminder that TTS only works in English. Please use English in chat. Thank you.
Okay, so this is the epilogue. Can I move this to do, because we are doing this right now. Looks nice. Now we have to restore them. Sorry, store them. That's the epilogue. And then we have this load. Okay, I am isolating assembly from our own stack. It doesn't cost us much. Okay, so we just made the prologue and epilogue slightly longer, but we are now storing the register information. I think there should be a way to do this. I've seen this error so many times. What's the solution? There has to be. I remember. So I have to define my own destructor. In the implicit destructor for assembler. What was the issue? Nice. So this is our new register, like a new signal handler. Let's run the debug version. I want to see the stack trace. Okay. And this looks good. Save. Oh, yeah. It should be RX. So this is half the work. It should still execute. It crashes. Let's see, where do we crash? Okay, we jumped to empty instruction. Yeah, I know. We are actually using RDI to jump into the proper address. Okay, I have an idea. We could do return into the target address. Okay, and this is fine. And the fact that we restore those registers. Okay, let's do it like that. Inside assembler, let's allocate stack. Or maybe not. Maybe it's better to use the stack from the operating system. We could, I don't know, just don't save stack pointer. is I have no idea what's with those reds, but whatever. So strange. I'm also thinking about using calls, but I'm not a big fan of call and read because they just pollute the stack, they access memory, which we don't need. I would really prefer jumps. Okay, I have a different idea. We are not going to preserve array x. Array x is just going to be special. Let's do it like that. Push R. There's not enough registers. Okay, so I will eliminate stack pointer. RSP. And crash. At what address? 0. I want to see this machine code. Oh, maybe it's too long. Maybe it's longer than 128 bytes. Let's try that. Nope. Actually, I actually don't know what's the issue now. Okay, I think we have an issue in our code. We are never using this exchange. So this is our code. We can now inspect it. Okay, I'll be right back. Our epilogue starts at the very beginning. Okay, so we are storing the array-x at this address. Nice. And then we are storing this address into array-x. All of the registers are saved. And then we are popping a bunch of the equally saved registers and returning. Okay. And this marks the end of epilogue. This is where the prologue starts. We are pushing them in reverse order. Then we are pushing RDI. That is our state here. Oh yeah, it's because we are loading this RSP here. We don't need to store the original RSP anymore. Remove that and that and that. Actually, when I was looking at some of those instructions, this exchange instruction. Okay, we don't always want to use that because it's using the locking. Okay, let's see if this works now. Nice. Cool. So we are back where we started, but now we are preserving the values of registers. We can actually show this because our assembler could have a widget similar to instruction. And let's implement the text now. Okay, so this is our instruction and this is the assembler. We can run the instruction. I have to zoom in to update the texture. Yeah, there it is. Could actually do this automatically when we finish execution. And now it contains A in this register. Okay, the next step is to set up a separate thread. So I just want to update the animation automatically after running the code. It still says 0. When I zoom in, it will refresh the texture and it will fix itself, but I would prefer if this happened automatically. I need a way to wake animation from arbitrary thread.
Wojciech Krawczyk says,
I am back.
Hey. We are getting somewhere. So now when I execute a simple instruction, it actually updates this executor that I have here. So this is the object that preserves the state of registers. Anyway, thread. I want a separate thread.
$64 as I can see.
Yeah. Okay, I did change some things. So I disabled I am preserving the stack pointer now correctly. So I don't need to set up separate signal handler stacks. Okay, I will do this in the absolutely identical way. Yeah, I'm not going to be creative. I will copy paste. We don't need that. This PRCTL, we need to include something. Okay, I need a separate stack for the child.
Adraquilmo says,
Uh-oh.
Hey,
Poor Jezina says,
Hello.
hey, hello. We are slowly moving this into separate thread, but we have to do some things differently. So instead of this funk, okay, this will be regular return, also here, and we just need to include ptrace header. So what we are doing here, we are allocating a separate stack, and we are creating a thread that will run there. Okay, the new thread is going to finish very quickly. It should even print some messages, if it works. Starting infinite loop. Done. Why do we print it twice? Yeah, I don't like the fact that we are printing this line multiple times. Oh, maybe we are not flashing this stuff. Yeah, I think prints from the separate thread may not work nicely. Let's see if our logging will work better. I think because we are using this clone, we may be getting some weird behavior. Clone is a very low level, it's a syscall. Maybe it's not properly setting up thread local or some C buffers. I have no idea. The thing is, when I execute it the second time, sometimes it prints exiting. Why is this printing the same stuff twice? This must be because of the C standard library and its buffers, I think. The nice thing is that it actually does change the contents of this object, so that's nice. I will just not print from this thread. If I don't call any C library functions from the other thread, it should work fine. Okay, and it's still running, so I guess it worked fine. We are creating a new thread every time. I don't know if it's a good idea, but it seems to work. So the register is set to 0, and when I execute it and refresh the texture, it changes to A. I think this thread should be reused. So let's leave some to-dos on the roadmap. So this stuff we finished. Now we will do this, but first, okay, this we done. I am abandoning this idea. The stuff that we've done is much better. I don't know how it would be possible to reuse the same thread, but I think it makes sense. And by the way, we are not freeing this stack. Couldn't do this. This will definitely be too large though. I think this thread should basically run in a loop and like wait for a signal from Automat to jump into a specific section of assembly. Okay, so we have this. Also, I think we should look into C++ threads, and we should try to use the C++ threads if possible. C++ threads would simplify a lot. They would, for instance, execute the C++ and C standard library initialization functions so that printf would work. And it's good to have working printf in a separate thread. Yeah, and I think this is going to be necessary if we want to have a proper widget. I mean a widget that like in real time checks memory and pulls like the register values with ptrace. But okay, let's switch to the design. This is actually going to be much nicer. So I've done this prototype now. So we have 3 objects. This is the prototype for instruction selector. Instruction, and then we will have executor or assembler. I think we have to rename it. Let's put rename into another. Task. I have no idea how this could be named. So a thread with a state. This could be called process. Computer, VM. No clue. Anyway, I can give you my process for designing this kind of stuff. So usually I start with a design that looks like that, where I do some stuff manually. I just need to understand the problem domain to create something like that, and my understanding of the problem domain continuously changes. Anyway, so this is like a very early design. It's going to look much nicer. When I started playing with this idea for the instruction selector, so here we have an instruction and the executor. The executor here contains the instructions, which is maybe how it should be. And this is for selecting instructions. Okay. So this stuff I think we can close. Yeah, I will start conf UI. Okay, and here is Krita. So usually what I do is I first give a prompt to the ML model and it gives me some propositions that look like so. It usually goes in its own direction, so I keep refining the prompt. So here you can see the prompts that I sent. And I use different models. Recently I'm using Flux. Flux is decent. It generates nice images, kind of realistic. It doesn't have any specific artistic skill. I tried Stable Diffusion 1.5. This didn't work because I used too high resolution. If the resolution was smaller, it would look better, like way better. It got confused because 1.5 works natively at much smaller resolution. So that was Stable Diffusion XL. It went in a totally different direction. It paid attention to the fan because I said the cards should be arranged like a fan, in the shape of a fan. And you can see like an Asian fan here. Or here, like extendable fan. They are not cards at this point. And then back to Flux, because Flux seems to be just way better at prompt following. Another prompt, and at this point I just kept refining this, but at this point I was kind of happy with how it looks. And I drew a small sketch showing what I want. And from this sketch I started generating, but not from scratch, but from like 95% or 85%. At this point, the image generator doesn't generate stuff from scratch, but uses my drawing as a baseline, but very rough baseline. So this is how the result looks, and the first result, this already makes me happy. I think we could work with something like that. But then I usually generate a bunch of them, and I generate them with different levels of attention to the source material. So as I'm decreasing this number, the results are closer and closer to my original image. You can even see that the position of roses match the roses that I had in my original image. I should remove that. I kept decreasing them, and each image has some interesting ideas. One of my favorite ones is this one, because of the deck of cards. I really like this deck of cards. I am taking it with me. It's great. Then I also tried increasing this value to give more freedom to the model to generate some crazy designs. With 95 it started trying some 3D images. And then with 100%, but a more accurate description, it was generating stuff like that. Really, really nice.
Wojciech Krawczyk says,
What model did this?
This is Flux Dev. And okay, so what do we need in this thingy? So instruction selector, okay, so what was done? So we have a nice deck of cards, the twisted one. Roses, I think roses are pretty much, we can find a decent image here. Some of them are very interesting.
Nice.
So the roses will be instruction selectors. I would like to animate them between different stages so that they will be small and close, and when you click them they will move out and a couple more flowers will pop out and they will open. And they will have label. Okay, actually let's try with labels. So I don't know how to show this text so that it's readable. But there is one more thing that we need in our instruction selector. If we look at the prototype, so the roses will be used to represent those buttons. The flags below, those 4 flags below, they will be used to represent the size. Or maybe not size of the register, but size of the... Oh yeah, this will be that. This will be the size of the operation, how much bytes we are processing at a time. We also need those filters, like selecting from like an array of images. We should be able to select, hey, I want to read this register, or write to this register, or access memory at this position. So we need like a matrix of buttons. Can I move? Stuff seems to be broken here. Yeah, now it works. So we need text on roses, we need to have a matrix of register filters, kind of 4 buttons for each register. I'm still thinking about different ways to arrange those buttons. So in x86 you can have at most 1 memory operand. So they are mutually exclusive. So I could have...
Poor Jezina says,
Did you create a tall draw sketch before you started programming?
I actually started in Inkscape. Okay, so this is a very wide button. And what I'm thinking is that we could have a register icon. Actually, I had some really nice images for registers. Where are they? Let me check some things. Maybe I have them here. Yeah, so this is an axolotl, a creature that we will use to symbolize first register. So, okay, I will use emojis for now. Emojis are easier to work with. Let's use... Okay, so Inkscape doesn't know how to show those icons. Let's grab something from here. Can I do that? Good enough. Whatever. So I could put like 16 registers side by side, and here okay, I will just use this to represent this. Okay, this will be a very long line. And for each register there would be 2 buttons here, kind of on this line. This will be very long. Let me calculate how long. So if we use 8 millimeters per register, the whole thing will be 12 centimeters wide. Is this acceptable? Okay, this one is 10 centimeters wide, so I think 12 is not the end of the world. Sorry, yeah, 12. It will be 12. Or 13. So it will look somewhat like that. There would be a line in the center. Those will be buttons for... like only one of those will be selected at a time. Or actually no. Yeah. Two of them can be selected at a time, but only from the same row. Because the top row is going to be the reading from memory. In x86 you can specify two registers as a memory address, and one of them can also have a scale. And there are plenty of options here.
Wojciech Krawczyk says,
I saw your app gatekeeper. What tool did you use to do? Gayugi looks so good to eye. P.
Hey, thanks. It's JavaScript. It's just... what do we have here? Oh, actually no, it's not just JavaScript. The menus, like the tables, when they are like moving on screen when I click them, this is done with HTMX. Yeah, this is the library. It's a decent one. It combines very nicely with CSS animations. I'm still looking at this stuff. Maybe I will skip those memory buttons. So we'll have like 16 registers from which we can read, and there will be one more option which reads from memory.
I have to go, Saya. Keep doing that, you are great.
Thanks. See you around. Okay, what else we could do? We could visualize the memory access as a brain. Because I can select, for example, that I would like to read from this register. Yeah, but the memory expressions in x86 are strange. They have so weird constraints. There can be two of them, and one of them can have a scale. Okay, I am actually storing just 15 registers. So maybe in the 16 I could put a brain, and that would mean, hey, I want to read from a memory or write to memory. And then there will be like a separate widget that allows me to parameterize how do I want to read from memory. For example, a much smaller 4x4.
Mahamad says,
Hello.
Hey. So here we could say what is the base address and what is the index. And next to the index we could also select a multiplier, whether it's multiplied by 1, 2, 3 or 4, something like that. And that would only appear if you select memory here.
Sorry, what are you doing?
So we are designing an environment for working with assembly. Yeah, it's a long story, really. Actually, like last week I published like a devlog, a short devlog on YouTube. So there is like a 5-minute introduction to what we are doing. This is probably the best place to start. The most recent one. This is the one that's interesting. I think this is the way to do it. This will be a table. This stuff here is the scale of the index. This is 1, 2, 4, or 8. I think this should appear like somewhere here, only when we open the brain. Okay, now let's look at the buttons. On each button, we should show the result of clicking this button. So here we will show a deck of cards, something like this. I have no idea how to display this. So in each section we'll have a deck and a number showing how many instructions will be available after clicking this option. Similar to our prototype. Okay, and below we will have our pile of cards with roses. So we need to design this table above, how it's going to look like. But this is roughly the structure I think we'll go for. We also have some space here. I have no idea what we could put here. Okay, so let's get back to to-do list. So this is our matrix of register filters. I'm still wondering whether it makes sense to... Maybe we could align this in a 4x4 grid. Probably not. Yeah, so this thing here, this huge like selector, yeah, it's just a bunch of toggles. We'll do it like similar to those here. I mean, they will work in a similar way. They will look nicer, hopefully. Okay, so I'm leaving this as to-dos because I still want to run them through Stable Diffusion. We actually so we have plan, we still have to do the and after we do that, that would be it. So our instruction selector will be looking something like that. Yeah, like some of those. I think I will use the nicer roses, the 3D ones. They will still look like images. Those are very pretty. Okay, and then we have the instruction. I've been thinking hard how we can display instructions. I think the initial plan is going to be hard, or maybe let's leave it for later. First we will design the executor. Because the plan was for the instructions to align so that if an output of one instruction goes into other, I wanted them to be vertically aligned. I think we could instead have a sort of a braid pattern where each register will just flow to the next instruction. Yeah. I missed the background, doesn't matter. Now it's better. So, the executor, how we want the executor to work. What do we want from it actually? It should display the state of registers. And our plan is for each of the registers to be displayed as an army. So like an army, like a group of soldiers. They need to stand somewhere. So in Automat we use this visual kind of metaphor where you are looking from top onto like a flat surface. Okay, so we'll have that. And it should point to it should have a pointer. And it needs to have buttons for stepping through.
Farita Bree says,
It has been so long.
Hey, yeah. I see you have a very fitting avatar.
Yup.
Comes to this, I have no idea. I was also thinking about showing this as checkerboards, sorry, not checkerboards, like chessboards, like, because they are 8x8 and they are black and white. Which is exactly like registers. Okay, I think we will start with let me still think. I mentioned we will have two kinds of instructions. They will be very basic instructions, which are just representing the MC inst, and something more generic that can like dynamically select what you need. And we will only do the basic ones now. Oh yeah, speaking about this selector, in addition to index scale, we also need an offset. Okay. Let's start with maybe the registers. We have some here, so those are our ideas for different icons. Let's see what we can pull out of Stable Diffusion, Flux. I have no idea how good it's going to work because I have the TTS also loaded on my GPU. It's not particularly fast. Yeah. It's fairly slow. But at this resolution, flux works the best, so making it like decreasing this or increasing this would have negative effects. This is not bad. Like, we should actually evaluate it when it's in a smaller scale. Okay, I cannot unzoom further. Let's try at 512 or flux resolutions. What is the minimum? Okay, should be able to do at 512. Okay, this is even slower now. Oh, it's because it created many of them at the same time. Where do they live? Do they live in Brazil? I think in Brazil. So let's then generate one more with a different country. Those are not bad images. They don't show what we want, but they are interesting. I guess the model wasn't really trained on the images of this animal. I guess this is the closest. They are good, actually. I also wanted to see if we can do something from top down. Maybe something like that. It doesn't have to be realistic, right? We'll have an army of those. Switch to illustration. Yeah, this is pretty much... I mean, not pretty much, it shouldn't have any whiskers. increase the resolution because I want to see if at higher resolution maybe it's going to look better. Nope, not really. This one was pretty nice. We could cut it out. It shouldn't have ears. Okay, let's go with this one. I will try to change the model now. Because Excel models, they can be controlled using those control layers. Let's try it. Maybe style. Let's try it. So we could actually paint regions. And there was a way to do like a regional generation. Okay, I will remove this stuff. Because the flag is red, I cannot really see if I erased everything. But okay, we will need to move its hands. Or maybe this one hand. And we can remove the whole background actually. Maybe I will try with flags. Okay, so we can provide reference images of axolotl. Let's try it. And this is nice. This is AI generated clearly, compared to all the others. I think this one was good. I see, I messed up. Now let's try again. Something doesn't work. Let's create a selection here and try to invert and expand.
Wojciech Krawczyk says,
Do you still play Tibia?
No, I actually never played Tibia. Okay, this expand works terribly. It doesn't fit in the picture at all. Okay. And I can use the
I thought that you said that Tibia inspired you to start Automat. 315. 45 your screen right.
I don't think I've said that. I used, or maybe I said something I didn't mean to. It wasn't because of Tibia. Okay, I'll use this manager to install extensions.
My bad, but check stream, you said that. Haha.
Okay, we did install that IP adapter plus. Okay. This is probably the important one in paint nodes.
Low pass effect.
Yes, this is the one. Okay, so let's try restarting Comfy UI. Okay, Flux is very bad with expansion. I think. Let's try this. That seems better. Actually, let me try using those reference layers. Maybe we should use higher image size. It's not that great. I mean, the references definitely work here. Putting a reference into a stable diffusion Excel, it really follows it. Let's do those. Actually, the end. Okay. Okay, I had some models missing. I hope it doesn't break the stream. What I really want, I want a very simplistic image of this axolotl holding a flag. Already models, still downloading. Which flag was good? They all seem kind of broken. Maybe this one is probably the best. It takes a good chunk of the picture. That one was even better. Maybe remove this. So this is our flag reference. We're still downloading those models. Wow. I haven't heard about those. This is probably like a new type of model, illustrious. Still downloading. So this is my reference for a flag. It's still downloading. Wow. Okay. Interesting. It's illustrious. It could be probably more commercially friendly. Okay, I had flags. Come on. I will just start config again, and when it's downloading, I can compute in the meantime. Okay, which of those was the best? This one.
What games do you play?
Recently Baldur's, before that Factorio. I do like RPGs. I also played the Rogue Trader, another RPG, Warhammer Rogue Trader. Very good one, I think probably the best Warhammer RPG so far. Let's go with this one. It's not bad. Or maybe let's generate 10 of them.
Milno RPG 2.
I used to play MMORPG, but the MMO doesn't really bring much interesting things, at least for me. V-Rising, I did play V-Rising, but I did play it privately. I mean, not single player online, but not with random people, just with some of my friends. Okay, these are decent. Once we have 10, we will pick one and we'll go with it. I don't want to spend so much time on just picking the register images.
So it is interesting that you want to automate games and you do not play an MMO.
Yeah. I think single player games are just as bad at those things. Valheim, for instance. I mean, I play online games, just not MMO. I don't think it's just fun to play with random people. Interesting. This one I will just discard, it's garbage. I think
I do not play single, so I do not know if grinding and single players exist too.
oh yeah, they do. Okay, this one is cool. This is fairly looks almost like axolotl. We could work on this. I don't intend, but we could. And I think it will tile nicely if we have an army of those. I am discarding the bad ones immediately. I have no idea how this will come out. Let's see. It doesn't make sense, the description. The model, I cannot even picture it in my head, so I don't think model is going to do that. But let's see. So this is a good picture for a register. This one would also be interesting. It's very detailed. A box with a hand would be nice. It's funny that it generates blurry images. This is also nice. This is good. We could just remove this guy and it's passable. Okay, I will grab some food. I'll be right back. Okay. This looks like a winner. Okay, what was the C? C was circus. The images of the bird are terrible. It has a very unique appearance, this bird. I will try this. So this is our Dodo reference. Let's see if stable Excel will work. I will try some more. Why does it have two heads? Okay, let's try Stable Diffusion 3. This is another model that's supposed to be good at prompt following. It's not what we want, but better. You know what, maybe I can help it a little bit. Okay, maybe I will do something like that. Flux and strength 75%. it keeps losing it. Okay, let's save this and reopen Krita. Hopefully after I reopen it should have the reference working. So what is that? Why does it say it's missing? Okay, we need this Redux def. This is what we need. Let's see how to install this. This will probably be somewhere in the conf.ui interface. It was tiny. Okay, let's try restarting Comfy and then restarting Krita. And then check the log. Actually, the log is here. When was it modified? Just now. Where should I put it? Search path. Restart the server. I will just try restarting again. Hopefully this will help. Okay, apparently that's it. No idea where to put it so that it finds it. Oh, actually it found. Yeah. Okay, that log was just, it covered several instances. Okay, this is bullshit. It has the model reference now. Maybe I have to restart Krita now. Again. Let's reconnect. That should recreate the log file. Okay, so where are the others? For example, this one. It's in IP adapter. It's in the same directory, with the same permissions. Let me try something. Maybe I can pass flags here. Oh yeah, and now it's downloading those control nets. Let's skip the dodo for now. The next one would be a chick. That chick looks angry. Oh, and he even has a signature. How nice. So this is our egg. Amazing. I have no idea what's that. Oh, because I used ag, not egg. Yeah. It probably had no idea what I mean. some more. This one looks good, we just have to fix the flag. I think this is my favorite so far. Or this one. Hard to say. Okay. That was the source. The next one is going to be the gravestone. Okay, it did download something new. Not here, but maybe in other directory. Anyway. Yeah, they are good, those images. Yeah, this one even says 2017 or 7. The next one is a tent. And this one is just too good. I would like to reload the models now, so restarting Comfy. Nice. References seem to work now. Okay, let's put a dodo. Showing a dodo. Holding a red flag. I probably need to update stuff. That part was working, so we have the models now. Is it still fetching? No, it's not. Okay. I just broke my comfy installation. And it's fixed. Nice. Let's go here, try to reconnect. Yay, it's running. Hopefully now it will show us a proper dodo bird. I think they are extinct, right? It's way better than it used to be. Let's add one more reference. This will be the flag. Okay, let's make a couple of them. I think it caught the right style. Okay, let's grab this one. This is the AX. We can add one more reference. This will be the AX. I think I will remove this raised flag. Oh, it suddenly got very, very fast. After updating, it's suddenly 30% faster. Nice. So I am sending this as a reference, so that maybe it generates something similar. Okay, let's get more of those. I think I will reduce the influence of this thing. Shape is there. I don't know why it's generating so... Maybe we can use this. This is the DI, I think, as a reference. For some reason, whenever I use references, the stuff gets blurry. Again. The problem is that any reference seems to cause this issue, this blurriness. And when I remove the references, suddenly it's super sharp. It's not from Australia, it's from Madagascar.
Where you do BPM and diagrams.
I don't know what you mean. Yeah, so passing any kind of reference will cause the image generation to come out blurry. Maybe there is something else that starts with letter D. Let's try a dolphin. Dolphin should be very different from all of the others. I mean, like, it uses a very different associations, so it should be easy to remember. Hopefully. Not bad, not bad. Hey, and this one is very nice. I think we can use this. It's much better than Dogo. It also looks kind of evil. I mean, it's also pierced by the flag, but I guess we will solve this somehow. So this is our DX register, and let's pick the others. So DX, box, that was the BX. The CX. And then we should have source index, which is going to be this. I know this isn't very sharp, but it's going to be super tiny, so I will go with this. Okay, we should have an image for the base pointer now. Okay, it's called tarp tent. I am adding high quality because they are just coming so blurry. And they look very similar to the circus image, which I don't want. This high quality seems to have almost the opposite effect. I have no idea, I'm just trying to force the model to picture base. I thought that tent will be a very nice representation for a base. Or maybe a camp. This is also interesting. It's even hard to say what it shows. It's a couple of stones. Let's generate more. I like this. Camp is a nice idea. Yeah, something like that. This is what I was looking for. It has a nice feather around the edges. Something I could use in the stream, actually. Another one, nice. Okay, the next is stack of pancakes. I guess in medievals they didn't had pancakes, so cake maybe will work better. This is a good one. Get rid of those. I think this one. So this is the stack pointer. Okay, the next one is the... What's the name of this? It's not Stonehenge, Moai. Maybe I can remove high quality. I have no idea if this actually helps with the quality. I am discarding all of those, they are so bad. I think this one is best so far, but the head is too small, everything else is too large. This one looks nice. Wait, what register is this? I think this is R8. Here the composition is almost perfect. I just want a Y head. This doesn't seem to work that well. Let's try with different statues. I think this has bad connotations. It's like US was conquered by Soviet Union. I mean this... I could go with this head with a flag sticked next to it. That would be good enough. What is the name? Is this just called David or David of something? Yeah, it's just David. I mean, we could use the actual Damn, this isn't bad. Yeah, let's go with this one. So this is our R8. And the next one is going to be interesting. I don't want to show just a piece of shit with a flag sticked into it. But maybe a poo emoji will work. I cannot complain. This looks good on the first try. So this is our R9. The first one was the best, everything else looks crappy. And it's just perfect. Some of those pictures are really nice. I want more. That face. To fit with the others, it needs to be a complete image. This extra hand. This is actually what I was going for. It's just... maybe let's try going with this. I will just get rid of the flag. On this red around, can I just select this red part? Actually, invert, delete, there we go. Now this part in the center, I want it to be brown. And now let's set up like 80% strength and refine. Nice. Let's have a couple of options. So that was R10, I think. And the next one is going to be a castle. And the castle would be boring. Maybe it could burn or something like that. This one so far looks the best. Okay, this one is my favorite now. Okay, this is our R11. Next one is going to be a guard. That would be boring.
Says, "Hello Damien. This is a reminder that TTS only works in English. Please use English in chat. Thank you."
Yep. think this could be nice. It's just we just need a better composition and no artifacts and higher resolution. This is good. This is good. I preferred this one. It's just we need the lower half. Oh, come on. Okay, maybe you can work with this. Let's transform this. Okay, that was... Okay, this could be good. Let's try to refine it. Why is this so blurry? Actually, no. Let's get rid of these blurry ones. We need a background. Let's try to expand so that this should be used and yeah, flags should fill the rest of the picture based on this image here. Okay, let's make a couple. Doesn't look bad. Actually, yeah, this is just the best one. Okay, everything else can be discarded. Okay, that was R12. Let's try to get some of the golf fields. I don't know if this will work. Yeah, I don't want an image with an image inside. Surprisingly nice. I think we can just make the flag. I think, yeah, this would be nice. I want to get some examples. Okay, so updating config had a really nice effect on speed of generation. Okay, so we are going to need a golf ball. We can grab one from here. And now we don't need it. I kind of like this hole here. I don't like the rest, so let's get rid of the rest. And that was one actually very nice as a base. I will just switch the hole to this one. Let's transform it a bit. Also put a golf ball here. Maybe make it larger. And also the flag. we need a better flag. Okay, now that we have something like that, let's refine it. Yeah, it's trying to remove the golf ball. I don't like that. I would like the golf ball to be a very important element of the picture. Let's go with this. So this stuff we can delete, and this is R13. This is really nice, a medieval slot machine. Wow. Wow. $770. Yeah, this is what we want. The heads, yeah. So unfortunately this seems like the nicest one. The problem is that it's full of artifacts. Or maybe this one. Because of the simplicity. Okay, let's compare them to other images. I think this one. Or maybe this. Yeah, let's go with this one. I think at low zoom it's going to be easier to recognize what this is. And the last one, the post box. Okay, let's try to refine this. It looks almost like a mailbox. Come on. I think I could use this one, except I will do something like that. Yep, and this is our R14. Sorry, 15. Oh, actually, there is one more. The icon for memory. I will try to generate some just to hit this style, this illustration style. It's very nice. I will get rid of the flag. I'm just asking for flag to get some consistency. Hold on. Okay, I'm adding being touched by a finger because when we are accessing memory, we are pointing to the memory. The registers always contain pointers. And for pointing, we will use the metaphor of a pointing finger. Called index finger, I think, yeah. Jesus, what a monster. No, I don't want that. Okay, let's remove full body. I guess full body must be messing up with this. Oh. Yeah, this is what I wanted, but not an image of an image. Please, just an image. maybe illustration would be better, because illustrations... Oh wow. I think illustrations, they often appear in medicine handbooks. Paintings not so much. Hello? There are some weird elements here, but generally it's not so bad. Okay, I think this one could be good. Let's just tweak it. First, getting rid of this weird background. Okay, let me start again. Nice. Okay, I like this hand the most, so I will grab this. And which brain looked nice? None of those. Maybe this one. Now let's refine. Okay. Some of those look nice. Let's go with this. Doesn't really matter. Okay. Now let's try to arrange them in a similar way as here. So this should force the... First I will save this image. Then let's make everything visible except the preview. Okay, so for each of the layers we will scale them to 256 pixels. Okay, not exactly. All of them. Now we have to arrange them. Small problem, namely that the base pointer is not here, but maybe we don't need stack pointer. Yep. Okay, I'm just trying to see if we can maintain style consistency if we do it like that. Too much. Let's go for 50% maybe. Actually, this is something that old Stable Diffusion would do well. Not Flux, because Flux is, it tries to follow commands. It's too, it pays too much attention sometimes. Yeah, it's losing too much detail. Maybe something like 10%. And this is a very subtle change, almost invisible. Okay, it is a little bit visible though, unfortunately. Let's try some of the cool models like the Chroma. I really like this one. No, it's messing up too much. Yeah, even on 5%, it's breaking the dolphin. Almost everything gets broken here. So no, we will not do this. I will close this without saving, then reopen. What I want to do is this stuff we can get rid of. One thing I would like to do would be to adjust the color balance. It says color balance, but I don't see any. Okay, it looks very bad here. I don't want that. Save this as PNG. From GIMP, I guess I can fix this. And there should be a way to select. quite white point exactly here. I don't like it. This white balance turns out it wasn't so bad.
Adrakurmo says,
Why a none as R12? Lol.
So there is this mnemotechnique which kind of relies on using things that are that invoke strong emotional response. I'm trying to see if this will help. I think it will. And it's also something that it's not as scary, I would say, as, a text that says R12. This is the best one. This is fairly well balanced. Nothing to do here. Okay, this needs strong adjustment. From this to this. Okay. Now let's scale them. Whoa, it's surprising how slow it is to scale the layers. Okay, something is not right here. It shouldn't take that long. Let's quit it. Show all the layers. Okay, I actually don't want to export them just yet. Now I would like to do this design. So we have our instruction selector. I want to grab this part. I can use box selection. It doesn't look great. Okay, slightly better. So this is how I would like the cards to look like. When it comes to the roses, I will run Automat. Just to compare which of them fit like the best. Those could work.
Were you using assembly at previous job?
A little bit, yeah. Not a lot, and that was a little bit of assembly, but in pretty much every architecture there is. Okay, I want to get a look of collage, like a photo collage, and I think this type of flowers is the best. I like it. When it comes to leaves, it's hard to say. Maybe also this. Okay, the roses, they don't have to be as large, they can be much smaller. And the background, I'm going to completely remove those flags. What happened here? Why is this suddenly so washed out? What happened here? Why is this so... Some blending mode, maybe? Okay, I will close this without saving and reopen this. I must have, I don't know, flipped some option, which I don't know what happened there. I have no idea, but now it's... yeah, the contrast is very high again, like it should be. Okay, let's grab this fun from here. I will select it differently now. It's a bit of work, but Why not? We have a deck of cards, we have flowers that can be clicked. And we should also add the flags below. So which flags do we like? These look nice. And grab those. Okay, I can select this manually. Okay, this text here, let's replace it with the text that we would like to have here, which are numbers. This is the number of flags, like 8, 16, 32, 64. Take some brushy brush and try to get rid of this. Oops.
Stacy Park says,
Hey, how are you?
Hey, I'm good, thanks. I think we can shorten those flags now. Maybe that will work. Yeah, looks good. Almost. And there is a trick to fix this with a brush. So just taking an eraser doing like a small movement like that usually helps. Krita has some very weird ideas about selection and so on. Okay, so this is closer to what we want to be. Now let's put some labels on the flowers, because the flowers are supposed to be buttons. We will have a couple different categories. What those were? Base math logic system. Okay. Okay, so some things in Krita are done really bad, like the inability to move the window, so you cannot see what you're doing. 3 pixels, I don't know, 50%. Should be 22. And one more. Was it logic? Yeah, logic. This is not exactly what the categories we will have, but we just want to have a nice design that will show us how it will look. So the idea is that clicking any of those flowers will cause it to grow. So let's grow one of those flowers. Let's move it out. have no idea what I'm doing. Let's say this is good. It looks weird, so you should look closely. So let's continue here. I don't know what other category of opcodes there is. Maybe jumps. Okay. And once the category is extended, and then here we will have, for example, or I know Boolean is the same as logic, so I kind of messed up. Maybe lowercase. Lowercase seems less threatening. What else do we have? Not. And actually, the x86 doesn't have that many Boolean instructions. I think we might have covered all of them. There are shifts. Yeah, there are just so many, only so many things you can do with Booleans. So this is how the opcode selection is going to look like. We have a bunch of flowers with categories. We click the category, it grows, and on the leaves we have specific opcodes. And we will use a lot of textures for this. We are not going to do procedural generation for the leaves, although we could, but this would waste too much time. Now, we can save this. Now we need the other part of our register selector. This is going to be all of the registers. Registers. And the widget that I drawn here. It's going to be fairly large. This is going to be the largest part of the whole thing, actually. think maybe I could grab this. Come on. I need to do everything manually. We'll shift this lower. Everything else will move up. So we'll have flowers on top. The flowers will be used to select a category of operation. And then here we will have this white table, which allows us to set input and output registers. Okay, I'm starting to like vector layers. Wow, it just works. Nice. Oh, I can even change the feel. Let's make it brown with black line. Or actually no line. Because the layer style automatically adds a shadow. So we have that. I'm not sure if... If that was a good color to pick. Okay, let's grab and start putting the registers there. Next is BX. So that was bx, next is cx. I think this dolphin should be more blue. And also it's very large. I think it's larger than the others. Okay, so those are 4 general purpose registers. Next we have SI. I would like to select or maybe not. It's not going to be visible, or maybe it will be. We could definitely work on this egg. Next is destination index. And for this one, I think we should add some white outline. I mean, white vignette. Okay, looks nice. Dolphin is unusually large. I think we didn't copy it properly. Let me copy it again. Okay, apparently this is the size. Okay, be right back. Okay, we seem to have a couple more minutes, so let's try to copy all of the registers. There will be a lot of them. You will have source and destination. Next is going to be this one, the base pointer. Nice. Stack. I guess we want stack, yeah. Okay, and then now we have the extra registers. I think I need to do the color selection here. Nice. This one is also fairly tall. I guess it fully utilizes the space instead of the others, which are mixed. Okay, I want to select as much as I can except the eyes, because they are white, but they should not be transparent. You pretty much always have to lower this. Nice. We are out of place. And we still have 7 more registers. Okay, this is just temporary, this is just a design, so we don't have to be super accurate with everything, right? Let's move them a little bit. I don't want them to cover the deck of cards. We can also move this thing. And this. I wonder what to put on the buttons, because some of them should be... It should be clear that those buttons mean to read or write. Okay. Now the icons. So this is just a design. In reality, there will be more of those registers to decide. Flux is really good at icon generation. This is just incredible. The deck of cards, we still have to fix the deck of cards to make it nicer. But I think it may be hard for the stable Flux to generate this shape. This might be nice. We could remove the nose. Let's try this. Generate some variations on this. Copy prompt. actually don't know what it picked, so let's try refine this again. And those eyes, they don't look healthy. I kind of like this expression. This seems shocked, but this seems focused. Let's try iterating on this. This is kind of scary. Okay. More variations, please. This seems cool. Okay, first we have to do the level adjustment. And now we can do the level color to alpha. I think this will be fine because it's going to be here. Okay, we have to scale it down more. Maybe like 8%. think it would look nicer if we had the whole face and we would clip it to this button. And this is pretty good, by the way. I need to learn how to do this kind of blending. It looks cool, really cool. Let's see, I can try this eraser mode. No. Okay, for today I will finish. I will try to push this tomorrow so that on Friday we can maybe finish the design. We still have a couple of objects left to design, like instruction and the executor, so still plenty of work. In the meantime, see ya.